Okay, so here are some properties, some definitions that I need you to know. These three are big. We're going to use these again and again and again. Reflexive, symmetric, and transitive. So if a relation is called reflexive, that means for any x in A, x is related to itself. So that means x would be related to itself, like that, right? Symmetric, when does that happen? If and only if for all x, y in A, so notice I put it in bold here, if x, y is in the relation, then y, x is in the relation. Okay, so you have to start with this. You have to start with this if. Transitive says if I have x, y in the relation and y, z in the relation, then what do I have? I've got the conclusion that x will be related to z. Okay, so here is my relation. I'm not telling you what if it's less than, divided by, whatever. I'm just telling you a bunch of ordered pairs. So first off, is it reflexive? So I want you to go look to see if every element is related to itself. So I see 0 is related to 0, 1 is related to 1. I can see by looking at it that 2 is in the set A that the relation is acting on. It is not reflexive because 2 is not in the relation, right? It's not in the set of ordered pairs. Okay, so it's not reflexive. Okay, so to be symmetric, if I see something, right? So it has to be an if then. If I see 0, 1 in the relation, that means I have to be able to find 1, 0. Oh, I do. Okay, so let's go for the next one. So 0, 0, that's kind of easy to go back to 0, 0. Okay, 0, 3. So 0, 3 is in the relation. I should see a 3, 0. Oh, it is not. So 3, 0 is not in the relation, yet 0, 3 is. So that means it's not symmetric, right? So if this, then this. Okay, so let's look to see if it's transitive. So this one takes a little bit more work. So let me get rid of my underlining things here. Okay, so let's start with 0, 0. Well, okay, let's do, if 0, 0's in there, and then 0, 3's in there, right? 0 to 0, this same 0 to this same 3, I should have 0, 3 in here. Oh, nope, it's not. So I have 0, 0 and 0, 3. Oops, it's supposed to be an and in the relation, but oh, wait a second, 0, 3 is in there. Oopsies. Never mind. Okay, never mind. 0, 3 is right there. Okay, so let's try another one. Let's get rid of those arrows. Okay, so let's try 1, 0, right? If I do 1, 0, so I can just have to find an ordered pair that starts with a 0. So I'm going to go 0, 3, right? So 1, 0 and 0, 3 are both in the relation. So that means that 1, 3 should be in the relation. It's not. So it's not transitive. All right, so let's look at this one. So actually, I'm going to let you do this one and this one because I think you're bright enough to be able to figure these two out. And oh dear, the power set. Oh, okay. I think you can do that one as well. Actually, let me do this one. Let me do C. So is it reflexive? So 0 is in the set and 0, 0 is in the set. 1's in the set A, so 1, 1 must be in the set A. So it is reflexive, right? So I kind of want to do the simple stupid case. Oh, did I say in the beginning that the set A, I didn't even say what the set, so I have to look up to see what the set A contains, and just because of what's being acted on, the set A must be just 0 and 1. Okay, so it's reflexive. Check. Is it symmetric? Ooh, okay. Symmetric means if I have this in the set, is the opposite, right? Is the order switched? Well, yeah, because they're both the same, right? And so it's symmetric. And then is it transitive? So this one's kind of weird. It doesn't go anywhere, right? So we say this is vacuously true. Remember that from the logic part? So it's all three of them. So that's kind of a weird one, right? All right, let's move on. I'm going to stop here and put it on the next video.